The SI system, also known as the metric system, is the International Decimal System of weights and measures. It is the basis of the standard units assigned to various physical quantities. Here is a table that shows the 7 base quantities and their metric base units, also known as SI units. And since different units are used in different measurements, it is important to know the basics of converting one metric unit to another. To do this, you must be familiar with the metric conversion chart, which is composed of the prefixes, their symbols, and the equivalent of 1 unit of each to the base unit. Rules in converting metric units. First, identify the metric base units. The identified base unit should be used consistently in the conversion process and should not be confused with other base units. Second, determine the prefixes used and their equivalents. This can be done with the help of the conversion chart. Third, write the conversion as a fraction. A fraction is composed of two parts, the upper number or the numerator, and the lower number or the denominator. The positions of the two units involved in the conversion shall be based on the unit of the given measurement. Fourth, multiply the fraction to the measurement you are converting, leaving all units in the answer. And lastly, cancel all units found on both the numerator and the denominator. Make sure that the only unit left is the same as the desired unit in the problem. A scientific notation is a more convenient way of writing very large or very small numbers. Instead of expressing the number in decimal notation, the number is shortened to a number multiplied to a power of 10. Hence, the two parts of a scientific notation are the number, which is also known as the coefficient. This is placed before the decimal point and has a value that is greater than or equal to 1 and less than 10. In other words, the number must be within the range of 1 to 9. The second part of the scientific notation is the power of 10, which is written as times 10 raised to a certain exponent that is either positive or negative. A positive exponent refers to the number of times the decimal point is moved to the left, while a negative exponent refers to the number of times the decimal point is moved to the right. For you to better understand this concept, let us have some examples. 1 billion. Since this is a large number, the decimal point must be moved to the left, in such a way that it reaches a point where only one number is found on the left side of the decimal point. In this case, 1. After that, count the number of places the decimal point has moved to the left. Since the decimal point has moved 9 places to the left, the exponent is positive 9. And the final answer is 1 times 10 raised to 9. Let's proceed to the negative exponent. The given here is this very small number with 8 zeros before the digit 1. Since this is a very small number, the decimal point must be moved to the right until it passes one integer. In this case, it's 1. The decimal point has moved 9 places to the right, and that gives the number an exponent of negative 9. Thus, the final answer is 1 times 10 raised to negative 9. The next example is 120,012,000. This is just the same process as the first one. Move the decimal point to the left and count the number of times it has moved. In this case, it is 8. Therefore, the exponent is positive 8. And the final answer is 1.20012 times 10 raised to 8. The last example is this value, with 6 zeros before 4. Again, move the decimal point to the right, count it, and that gives us an exponent of -7. The final answer here is 4.52 times 10 raised to -7. The steps of the metric to metric conversion, as well as the conversion chart, are shown here to assist you in your first steps in the conversion process. Sample problem number 1. Convert 5,000 kilometers to meter. In the first step, we have to identify the metric base unit. In this case, the metric base unit is meter, which is the standard unit of length. For the second step, determine the prefixes used in their equivalents. In this specific problem, there is only one prefix used, and that is kilo. Using the conversion chart, we can say that 1 kilometer is equal to 10 raised to 3 meters. Third step, write the conversion as a fraction. In determining the fraction, we first have to look at the given measurement. The given measurement is 5,000 kilometers. The unit of this measurement is kilometer. The unit in the conversion that is the same as the unit of the measurement should be placed on the denominator side. And the other unit must be placed on the numerator side, and that is 10 raised to 3 meters. Step number 4. Multiply the fraction to the measurement you are converting, leaving all units in the answer. At this point, all the upper measurements must be combined and must be divided by the lower measurement. Lastly, all units that are found both on the numerator and on the denominator side must be cancelled. In this case, it is kilometer. After doing that, we'll be left with 5,000 times 10 raised to 3 meters. But this is not the final answer. We still have to follow the rules of scientific notation. The next thing that we have to do here is to move the decimal point to the left. And since we move the decimal point 3 places to the left, this number should be added to our initial exponent, which is 3. 3 plus 3 is equal to 6, and the final answer is 5 times 10 raised to 6 meters. Problem number 2. Convert 0.00005 meter to centimeter. The metric base unit here is meter, the standard unit of length. The prefix that is used here is centi. And according to the conversion chart, 1 centimeter is equal to 10 raised to -2 meter. Before we convert this conversion to a fraction, let us first take a look at the given measurement. The unit of the given measurement is meter, which means that 10 raised to negative 2 meter in our conversion should be placed on the denominator side, whereas 1 centimeter must be placed on the numerator side. Next is multiply all the upper measurements and divide them by the lower measurement. Cancel out the unit meter, and this will be equivalent to 0.00005 centimeter divided by 10 raised to negative 2. Since we have a negative exponent on the denominator side, we can just move it to the numerator side, but its sign must be turned into positive. After doing this, the measurement would be 0.00005 times 10 raised to positive 2 centimeter. And since we have to follow the rules of scientific notation, the decimal point must be moved to the right. This movement of 5 places to the right is numerically equivalent to negative 5. This value must be subtracted from the initial exponent, which is 2, and that gives us 2 minus 5. The final answer in this problem is 5 times 10 raised to negative 3 centimeter. Problem number 3. Convert 275 milliliters to liter. The base unit here is liter, which is a unit of volume. The prefix that is used here is milli. Using the conversion chart, we can say that 1 milliliter is equal to 10 raised to negative 3 liters. The unit of the given measurement is milliliters, and that puts 1 ml of the conversion on the denominator side, and 10 raised to negative 3 liters on the numerator side. 275 ml times 10 raised to negative 3 liters divided by 1 ml. Cancel out ml, and the answer would be 275 times 10 raised to negative 3 liters. The decimal point must be moved to the left. These 2 movements to the left gives us a value of positive 2, which must be added to the initial exponent, which is negative 3. Negative 3 plus 2 is equal to negative 1. The final answer is 2.75 times 10 raised to negative 1 liter. Problem number 4. Convert 90 gigagrams to gram. Gram is the standard or the base unit of mass. In this problem, the prefix used is giga. One gigagram is equal to 10 raised to 9 grams. The given measurement is 90 gigagrams. This gives us a fraction of 10 raised to 9 grams over 1 gigagram. 90 gigagram times 10 raised to 9 grams divided by 1 gigagram. Cancel out the unit gigagram, and then our answer would be 90 times 10 raised to 9 grams. To express this in scientific notation, the decimal point must be moved 1 place to the left. And this adds 1 to our initial exponent. And the final answer is 9 times 10 raised to 10 grams. Problem number 5. Convert 3.2 milliamperes to kiloampere. In this problem, the base unit is ampere, which is the standard unit of current. The prefixes used here are milli and kilo. According to the conversion chart, 1 milliampere is equal to 10 raised to negative 3 ampere. And 1 kiloampere is equal to 10 raised to 3 ampere. Problems like this can be solved using either of the two methods. The first method is the two-step method. In this method, the first unit is converted to the base unit. After getting the measurement with the base unit, this measurement is converted to the desired unit. First step, converting milliampere to ampere. 3.2 milliamperes multiplied to the first fraction, which is 10 raised to negative 3 ampere divided by 1 milliampere. This is equal to 3.2 milliamperes times 10 raised to negative 3 ampere divided by 1 milliampere. Cancel out milliampere and the answer will be 3.2 times 10 raised to negative 3 ampere. This measurement will be our initial measurement for the second step. 3.2 times 10 raised to negative 3 ampere multiplied to the second fraction, which is 1 kiloampere divided by 10 raised to 3 amperes. 3.2 times 10 raised to negative 3 ampere multiplied to 1 kiloampere divided by 10 raised to 3 amperes. Cancel out the unit ampere. And the value would be 3.2 times 10 raised to negative 3 kiloampere over 10 raised to 3. Since we are given two exponents here, and the operation between them is division, we have to follow the rules of the division of powers or division of exponents. In dividing exponents, we just have to subtract the two values. And that will give us a value of 3.2 times 10 raised to the first exponent, which is negative 3, minus the second exponent, which is positive 3. And that would be negative 3 minus 3. The final answer here is 3.2 times 10 raised to negative 6 kiloampere. Again, in the two-step method, the first unit is converted to the base unit, and the base unit is converted to the desired unit. But if you don't want this long method, you can resort to the second method, which is called as the all-in-one go. This second method is just a combination of the two steps of the first method. (3.2 milliampere) multiplied to the first fraction, which is 10 raised to negative 3 ampere divided by 1 milliampere. And then multiply to the second fraction, which is 1 kiloampere over 10 raised to 3 amperes. Combining all the upper measurements and combining all the lower measurements, we will have this value. After this, cancel out all the units that appear both in the numerator and in the denominator side. And then the value will be 3.2 times 10 raised to negative 3 kiloampere over 10 raised to 3. This is the same equation as the first one that we did a while ago. Our final answer is the same as the one computed in the first method. Problem number 6. Convert 300 milliseconds to nanoseconds. The base unit here is second, which is the standard unit of time. And the prefixes are milli and nano. 1 millisecond is equal to 10 raised to negative 3 seconds. Whereas nano is equivalent to 10 raised to negative 9 seconds. First, we will solve this using the two-step method. In the first step, we will convert millisecond to second. 300 milliseconds multiplied to the first fraction of the conversion, which is 10 raised to negative 3 seconds divided by 1 millisecond. 300 milliseconds times 10 raised to negative 3 seconds divided by 1 millisecond. Cancel out millisecond, and the answer would be 300 times 10 raised to negative 3 seconds. This measurement will be our initial measurement in the next step. 300 times 10 raised to negative 3 seconds multiplied to the second fraction, which is 1 nanosecond over 10 raised to negative 9 seconds. 300 times 10 raised to negative 3 seconds times 1 nanosecond divided by 10 raised to negative 9 seconds. Cancel out seconds, and the value would be 300 times 10 raised to negative 3 nanosecond over 10 raised to negative 9. Once again, the powers of 10 are found on the numerator and on the denominator side. With this, we just have to subtract the two exponents. And that would give us 10 raised to the first exponent, which is negative 3, minus the second exponent, which is negative 9. Two negatives is equal to positive. Therefore, the value would be 300 times 10 raised to 6. And the unit of this one is nanosecond. But still, we have to turn this into a proper scientific notation. And the final answer would be 3 times 10 raised to 8 nanoseconds. For the second procedure, we will convert all the units in one go. 300 milliseconds multiplied to the first fraction, which is 10 raised to negative 3 seconds over 1 millisecond, multiplied to the second, which is 1 nanosecond over 10 raised to negative 9 seconds. Combining all the measurements in the upper portion and all the measurements in the lower portion, and we will have this value. Cancel out the units. And the value would be 300 times 10 raised to negative 3 nanoseconds over 10 raised to negative 9. the same as the one that we had a while ago. This will give us a value of 300 times 10 raised to 6, then moving the decimal point to the left, and then the final answer would be 3 times 10 raised to 8 nanoseconds. Problem number 7. Convert 1.05 decigram to kilogram. The prefixes here are deci and kilo. One decigram is equal to 10 raised to negative 1 gram, while 1 kilogram is equal to 10 raised to 3 grams. In the two-step method, the first unit that we have to convert is decigram, and this should be converted to the base unit, which is gram. .05 decigram multiplied to the fraction of the first conversion, which is 10 raised to negative 1 gram over 1 decigram. This is equivalent to 1.05 decigram times 10 raised to negative 1 gram over 1 decigram. Cancel out decigram, and the answer would be 1.05 times 10 raised to negative 1 gram. This is our initial measurement for the next step. 1.05 times 10 raised to negative 1 gram multiplied to the fraction of the second conversion, which is 1 kilogram over 10 raised to 3 grams. Combining the terms, 1.05 times 10 raised to negative 1 gram times 1 kilogram divided by 10 raised to 3 grams. Cancel out gram, and the answer would be 1.05 times 10 raised to negative 1 kilogram over 10 raised to negative 3. Subtract the exponents. Negative 1 minus positive 3. Our final answer is 1.05 times 10 raised to negative 4 kilogram. For the last part, the all-in-one go method. 1.05 decigram multiplied to the first fraction, which is 10 raised to negative 1 gram over 1 decigram, multiplied to the other fraction, which is 1 kilogram over 10 raised to 3 grams. Combine all the upper terms and all the lower terms. Cancel out the units, and the measurement would be 1.05 times 10 raised to negative 1 kilogram divided by 10 raised to 3. The final answer is 1.05 times 10 raised to negative 4 kilogram. If you have questions about the topic, just comment below. Thank you!